And finally, we're going to look at complex trinomials here, and I have a couple of examples. First example, if you change that middle number, I think you have a 15 on your note. It should be a 17. So how do you do complex trinomials? This is the hardest one. So we've checked for common factors. There are no common factors there. Is it a difference of squares? No. Is it a perfect square? No. Is it a simple trinomial? No. So when all those answers, when those 4 questions have been answered, you know you're down to your last resort, and that's a complex trinomial. So this is how you handle it. You take the first number, the 6, and you write out all the factors, and I do it vertically. So for example, 1 times 6 gives me 6, 2 times 3 gives me 6, and there's nothing else because we start over. What I then do is rewrite them, except upside down. So the 1 and 6 now would become a 6 and a 1, and the 2 and 3 would become a 3 and a 2, and I put a vertical bar. All right, so that's what I did with the 6. Now I take the 5 and I write out all the factors of 5. So I'm looking at the first and last term. So 1 times 5 is 5. There's no other factors, and I don't have to flip it. I only flip the first one. So what's going to happen, if it is a complex trinomial, it's going to result in 2 sets of brackets. The goal here is to find something that will multiply to that middle term, 17. Okay? So I'm going to use my magic pen, so it's going to disappear. So what I'm doing is I'm cross-multiplying. I'm going to take this 1, all right, and I'm going to multiply it with the 5, and 6 times 1 is 6. So I'm going to end up with 5 and 6. Can I get 5 and 6 to add up to 17? The answer is no, so that doesn't work. I move over 1. So the 2 times 5 is 10. 3 times 1 is 3. So now I have 10 and 3. Will that add up to 17? The answer is no. And you keep working your way across. All right. So 6 times 5 is 30. 1 times 1 is 1. So 30 and 1. 30 and 1. That doesn't work. So I'm down to my last one. If this doesn't work, it doesn't factor. So I have 3 times 5 is 15. 2 times 1 is 2. That'll work. I have to get it to add up to positive 17, which would mean the 15 and the 2 would have to be positive, which means that both symbols in here are going to be positive. So now that I know it's the combination is the 3 and 2, 1 and 5, I go like this. So the 3 and 1 are going to go together. The 2 and 5 are going to go together. The first term is going to be my x variable. The second one is going to be the constant. So the 3 will get the x, the 2 gets an x, and then the 1 and 5 go in the constant location. All right. So it may look a little bit different if you had a different teacher that taught you how to do complex. You can look at this way and ask yourself if you like it better. If you like the way you learned it better, which is probably the case, then stick with it. Okay? So let's do a couple more here. So the next one, looking at it, we got to take that 2. So 1 times 2 is 2, and that's it. So I'll flip it. So I got 2 and 1. Take the last term, 1 times 3. That's it. So now I quickly do my cross multiply. So 1 times 3, 2 times 1. So that would give me a 3 and 2. Can I get it to add up to the 5? The answer is yes, because positive 3 plus 2 is going to give me 5. So that would mean inside the brackets here, both terms are positive, so we'll have adding in both cases. I now have these 2 are going to be in the same bracket, and that's why I've circled them in red, and these 2 are going to be in the same bracket. So the top red, I'm looking at this one right here. That means I'm going to have 1x plus 1. So 1x plus 1. And in the second bracket, I'm going to have 2x plus 3. So 2x plus 3. And there you go. All done. All right. Maybe 2 more examples. And if you need more help, I'll do these 2 examples with you one-on-one so we can identify what your problem is. All right? So don't cross them out. Leave 5 and 6. So looking at number 3, 6. I've done it above, 1 and 6, 2 and 3. I'm going to write it the other way. 2 is just 1 and 2. So I need something that will give me a negative 7. So 2 and 6. So I'm just going to do this in my head now. 6 and 2. Okay, that's not going to give me a 7. 4 and 3. That would give me 7. So I've got a 4 and a 3. 4 and a 3. Now it has to give me a negative 7. So that means I'm going to need a negative 4. And I'm going to have to take away 3. So that means that both signs in the brackets are going to have to be negative. Both of them are going to be negative. I know that. Who's partnered up? These two are going to be in the same bracket. And these two are going to be in the same bracket. So I'll have 2x minus 1 and 3x minus 2. All right. And there we go. And you always check with distributing it out. All right. And the last one here. So the 4. So I have 1 and 4, 2 and 2. So I'll flip it, 4 and 1. I don't have to flip the 2 and 2. It's going to be the exact same. 18, though, that's a bit more of a problem. 1 and 18, 2 and 9, 3 and 6, 4 and 5 don't work. Okay. So again, let's just do this in our head. You can always write it out. So 18 and 4, is that going to give me 27? 18 plus 4, 22. That's as close as it's going to get. 2 times 18 is 36 and 2, or 2 times 1 is 2, so 36 and 2, way too big. And 4 times 18 and 1, that's way, way too big. So what that tells me is that the 1 and 18 is not one of our factors. So we go back to the start again, and we do the next one. So 1 times 9, 4 and 2. So 8 and 9. That's not going to give me 27. It gets me 17. 2 times 9 and 2 times 2. So that's 18 and 4. That's not going to get me there. 4 times 9 is 36 and 2. 36 and 2 can't get it to 27. So that tells me that the 2 and 9 is not one of my options. So what that tells me now, I'm down to 3 and 6. If it doesn't work, then it's not factorable. So 6 and 12, that's 18. That's not going to work. 2 times 6, 2 times 3, so that's 12 and 6. That's not going to work. So our last hope here, 4 times 6 is 24. 1 times 3 is 3. 24 and 3, that'll work. A lot of work to get there. It was our last option. So 24 and 3 will work. So that's, these guys will be in the same bracket, and these guys will be in the same bracket. Working on my signs here, it's plus 27, so that means that both have to be positive. So that makes it easy when I go to do my brackets. And I know that the first bracket will have the 4x plus 3, and I know the second bracket will have x plus 6. There we go. So I'll leave these last two, don't cross them out. And if you're having more trouble with them, we'll use those two for me to kind of go through, excuse me, and figure out what the problem is. All right. And like I said, if you had a method last year that you really liked, stick with that method. It comes down to, can you factor? That's all I'm really assessing. Okay, so for this, I'm not going to go through and actually do the factoring. I just want to identify what types they are. Okay, so that's all we're going to do here. So the first one, common factor is your first choice. 25, 40, and a 16. Now I know a 16 is not divisible by 5. I know it's divisible by 4. So are the other numbers divisible by 4? The 40, yes, but 25 does not divide by 4. So there's no common factors here. Is it a difference of squares? There's 3 terms, so the answer is no, can't be that. Is it a perfect square? Well, 3 terms, yes. You can take the square root of 25, x squared is a perfect square, exponent's even, 16 is a perfect square. So the test was, take the square root of the first term, so 5x, multiplied by the second term, square root of the second term, is a 4, so there's 20x. If we double it, does it give us the middle term, 40x? So therefore, it's a perfect square. Okay? It is a perfect square. Moving to number 2. Is there a common factor? No. There's no x in there's no x in both terms. There's no number in both terms that we can pull out. There's only two terms. Is it a perfect square? Well, it has an adding sign, so it can't be a difference of squares, and it can't be a perfect square because there's only two terms. Simple trinomial needs to have three terms. Complex trinomial needs to have three terms. So because it fails our first all four tests for us, we can say this one does not factor. So it could not common factor, wasn't a perfect square, wasn't a difference of squares, not a simple trinomial, not a complex trinomial. So it fails, all five tests. Looking at number 3, so you're going through this checklist, and this is what you need to have on your cheat sheet. Okay? Is there a common factor in those three terms? No, because there's not an x in every term, and I know 14 and 5 have nothing to do in common. So it's not a common factor. So common factor is out. Difference of squares, ds. No, because there's three terms. What about a perfect square? Can't take the square root of 14, so it's not a perfect square. Simple trinomial, st. It could be, because there's no term in front of the x squared, so we can go ahead and use the simple trinomial. So in this case, you're going to have a simple trinomial to deal with, if it factors. Number 4 then, just looking at the timing here, got lots of time. Common factoring. So I see 5, 10, 25. So I'm going to actually do a step here just to see if it has to go further. So there is common factoring. So I know 5 is a common factor, and it's the variable with the smallest exponent. So it would be the x squared. So I'm going to pull the x squared out. That's going to leave me with x squared minus 10 minus 5x to the 5th. All right. Now here is a clue for yourself. We did no factoring so far other than common that involves x to the 5th. So odds are this x to the 5th term pretty much tells you that there's no factoring possible here. Okay, so that's as far as it went. So it was just a common factoring question. All right. After common factoring, if you do common factoring and you end up with an exponent greater than 2, if it's not a thinking question, then you're probably done. If it's a thinking question, I've likely thrown a little bit of a twist in for you. Okay, the 5th one. Most people are going to know exactly what this is right away because there's 3 terms. So those are common factors. 31's divisible by nothing useful, so it can't be common factor. It's not a difference of squares, so common factoring's out. Difference of squares, there's 3 terms. What about a perfect square? I can take the square root of 4 and the x squared. 21, can't take the square root of it, so it can't be a perfect square. Is it a simple trinomial? The answer is no, because there's a number in front of the x squared. So it has to be a complex trinomial. And that's your only option. If it's not a complex trinomial, it does not factor. All right. And our last one, any common factors? 9 and 100 have nothing in common, so common factoring is out. What about difference of squares, ds? Well, there's 2 terms. There's subtraction. I can take the square root of 9, I can take the square root of x squared, and take the square root of 100. Meets all my criteria, so it is a difference of squares. So that's going to be the challenge at the end of this whole process. So when you look at the homework here, yeah, there's a lot of homework. This is technically, if I was going to teach this in a traditional classroom, a lesson probably went 2 days, and the homework's probably going to go 2 or 3 days. So it's a huge component I've put together for you because some people are going to go through stuff quick, some stuff quick and struggle, and vice versa. So you're going to be taking 2 to 3 days here. Okay. If you have trouble, you need to get the help from me, and that's what I'm there for. All right. So good luck with it. And like I said, if you have any problems, you want something clarified, make sure you ask. So write it down in that book so that you can ask me when we see each other.